OpenAI just released a paper that could change the course of AI, and I'm going to explain it so that anyone can understand. But first, what's the real problem? When ChatGPT answers you, no one can explain exactly why it chose those exact words, not even the OpenAI engineers. It's a massive black box with billions of parameters making calculations no one can trace. Now imagine this in a hospital. The model misdiagnoses and a patient dies. The lawyer asks, but why did the model make this decision? And the answer is, we don't know. This lack of clear explanation is why AI hasn't fully entered industries like medicine or finance, where decisions must be auditable and trustworthy. It's not just about how well AI performs, it's about understanding why. OpenAI's solution is genius in its simplicity. They trained AI models where 99.9% of the connections are literally zero. Only 0.1% matters. And it seems like that would make everything worse, right? Wrong. By forcing the model to use fewer connections, it learns to be more efficient. And every connection that exists has a clear purpose. They could map tiny circuits, some with just 12 small components and 9 connections, and explain exactly what each part does. Here's one example from the paper. A circuit deciding whether to close a code string with single or double quotes. It works in 2 steps. First, an MLP layer detects quotes and classifies the type. Second, an attention head uses that classification to copy and correct the closing quote. Zero mystery. You can trace every calculation. And here's how they proved that it wasn't just luck. They removed each node from the circuit one by one, and task performance collapsed. But when they removed the rest of the model and left only that circuit, task performance still works perfectly. So that means each small circuit is both necessary and sufficient for that specific behavior or task. Now, this could unlock new uses for AI in places that demand trust and audit, like hospitals, banks, or self-driving cars, because now when something goes wrong, we can point to exactly which node failed and why. If you want the full paper, reply in the comments and I'll send it.